So far in 1.5 we've talked about what inverses look like, how we determine if they are inverses, but here we're going to go a step further and say how do we actually find inverses algebraically. You can't do it on every function, but there are a number of them that we can. This is one of the trickier versions. If you can do this one, then you can probably do just about any one in the assignment that you'll see. So first of all, to do this, we have two steps. Number one is going to be take this original function and switch x and y. That's the definition of an inverse. Second step, last step, is going to be solve for y. So that's going to be the tricky part here. And we know that if it has a plus minus in the end, then it's not a function. So we would have to be a little bit careful about how we deal with it if the inverse is not a function. So let's take a look at this one. F of x equals x plus 3 over x minus 2. Now remember that f of x is the same thing as y, so that's how we'll be able to flip the x's and y's. That means that I'll change the y into an x and I'll change the x's into y's. So y plus 3 and over y minus 2. So that's step one done. We've switched x and y. Now to actually make it in function form, see if it is a function, we have to solve that for y. This is the tricky part. This is one that you don't want to miss because it'll be a couple of steps of tricky algebra here. First of all, let's get rid of the fraction. We can get rid of this fraction by multiplying both sides by y minus 2. No one likes fractions. Let's get rid of those. So that will mean y minus 2 cancel out. We'll be at y plus 3 over here. Over on this side, I'm going to distribute the x to those two, so I'll have yx minus 2x. That just gets everything out in the open and we can go from here. Now we want to have y by itself eventually, so the next thing I would do here is to make sure that the algebra works out. That is to get all the stuff that involves y over to one side and get everything else that doesn't to the other side. To do that, I would add the 2x to bring it over here. I would subtract the y to bring it over there, which means the next step we'll have yx minus y equals positive 2x plus 3. This next step is where you really got to pay attention, because this is what will help us get it solved for y, and that is we are going to factor out a y from both of those so that we just have one instance of y. We're going to take y out, and if we take it out of this one, what we're left with is x. If we take y out of y, it's division, so we leave a 1. We don't leave a 0 there, but it's going to be x minus 1, and then over here we have 2x plus 3. We're almost done, because now y is just in one spot. We can divide both sides here by this entire chunk, by that factor, and so now we can say that y equals 2x plus 3 divided by x minus 1. And if you graph that, you'll find that that actually is a function. You'll also be asked at times to determine what the domain is here. Notice that the domain has a restriction down here that x cannot be equal to 1. And so we would say then that the domain is negative infinity to 1, 1 to infinity. And if you really want to get picky here and say that, just let your reader know, or whoever's reading the problem know that this is the inverse, then we could indicate it by doing this inverse notation. F inverse of x equals this thing right here. One thing I may not have mentioned in previous examples is that whenever you have this negative 1, it looks like it's an exponent, but that actually means inverse. So the way we would say this is f inverse of x equals 2x plus 3 over x minus 1.